everyone, and welcome to Research Recap, brought to you by Arbor Assays. In this series, we dive into fascinating studies conducted by scientists around the globe, exploring how they're using Arbor Assays kits to unlock new discoveries. I'm Cassie Shoemaker, Sales and Marketing Manager here at Arbor Assays, and I'm excited to highlight the amazing work being done in labs like yours, share insights, and take a closer look at the tools driving innovation and research. So let's get started. Today, I'm joined by Monet Gomes. Monet is a PhD candidate at Arbor University in the College of Forestry, Wildlife, and Environment, studying sexual selection on the white-tailed deer antlers. She is originally from Fresno, California, and her research interests include reproductive ecology, behavioral ecology, and life history strategies. Welcome, Monet.
Thank you for having me, Cassie.
Thank you so much for being with us. If we want to get started, and you can tell us a little bit about your project and what brings you to the white-tailed deer, what you're interested in, and what we can expect to hear more about.
So when I finished up my undergraduate research, I was interested in evolutionary ecology topics, but also merging these topics with a species that is under a lot of wildlife management. So white-tailed deer are kind of the perfect intersection between sexual selection topics and management topics. So that really drew me to the deer world. I love how relatable they are as an animal. Pretty much everybody you meet has some kind of a story with a deer, and they can immediately connect with you on that level. But this research that we're going to be discussing today is from my master's thesis, and it's titled Androgens, Antlers, and Sexual Selection, Testosterone's Relationship to Reproductive Success and Associated Morphological Characteristics in White-tailed Deer.
Awesome. That's so exciting. Yes, even just hearing you talk now, I can definitely relate to my own white-tailed deer stories up here in Michigan, just as much as you can down in Alabama. So that's really, it's a nice connecting thing for a lot of us, I think. So can you talk to us a little bit about the experiments that you were setting up and what you were hoping to see?
So our primary objectives for this study included mainly investigating the relationship between testosterone, sexually selected traits, and how these ultimately related to reproductive success on an annual level for white-tailed deer in our population. So a lot of people are really familiar with testosterone and how that can kind of increase characteristics such as aggression or behavioral dominance, and this is definitely the case in deer. There's been a really strong link demonstrated between testosterone and the annual antler cycle for deer, and testosterone and some of these aggressive behaviors that are really important for breeding for deer. But there hasn't been a lot of data that looks at how testosterone might actually play a role in the number of offspring that they're producing per year. So that was kind of our approach with this study. We utilized data over a long-term research project that began in 2007. At the time that I did this study, I had access to 10 years of data, which was pretty great as a master's student.
Yeah.
We had 82 individuals that were captured over 228 times over the course of this study that I could analyze.
Wow, that's a great sample size.
Yeah, it was great. And one really unique thing about this population is that even though they are inside of a fenced-in area, it's over 170 hectares, not acres. So it's quite a large area. They do receive nutritional supplementation, but other than that, they're freely behaving, freely breeding. And so we really get to get a snapshot of these deer every single year by darting them, and then retroactively look back and say what characteristics might have made them successful and how many offspring did they produce within a given year.
Yeah, that's a really unique sample set that you've had access to. What a wonderful thing that you got to be a part of. So you talked to us a bit about testosterone and why you were so interested in studying it and how it relates to what we know and what we might still have left to learn in these deer. And I know that you used our Arbor Assays testosterone ELISA kit to study it. Can you tell us a little bit about how you were introduced to Arbor Assays, the company or this kit in general, and anything that this kit really helped you accomplish?
So I was definitely not super familiar with a lot of the lab work that went into hormone assays or anything of that nature. I had received a lot of mentorship from somebody in my department, and she said that Arbor Assays was actually a really good company to look into just because the kits were very reliable, used for a lot of different species, and very simple to follow. If you purchased a kit, you were going to get everything that you needed. And so, as somebody who was beginning into this for the first time, that was very encouraging to me. The customer service was also very helpful. I was able to go back and forth with people from customer service. They guided me to how many kits I should purchase for the samples that I had, what I
Good.
should do to validate them, and then led me to the direction of studies that were in animals similar to white-tailed deer that could help me further confirm that these kits were going to work for what I needed.
Oh, great. I'm so glad to hear you had a great experience with our customer service team, and also that you found our kits reliable and more importantly, could give you the answers that you needed to keep your research going forward.
Yeah, they did.
Um,
10 years of data to run through the kits was a hefty
yeah.
task, and they definitely performed well.
Oh, perfect. That's so great to hear. So can you tell me a little bit about how you designed your and set up your experiment?
So this project had been ongoing since 2007, as I had mentioned. So some of the data that we had been collecting on this population, first of all, we would dart them every single year. We would dart adult deer and measure morphological data on them. So this would include like body size, antler size, um, other variables that might be important to their breeding and their life history. And then we also collected genetic data from tissue samples and then collected blood serum from the deer. So when I came onto the project, I was able to use that blood serum that we had been collecting over the last 10 years. And then I also was able to utilize the pedigree that we were able to establish in the population through these genetic samples. So the pedigree is really kind of what's giving us the answers to what's going on here.
Great.
For almost every individual, every adult that we have in the population, for a given year, we know how many offspring they had, who they bred with, and what those offspring are, like how they're developing in their own life.
Yeah, that's great. So that sounds like a really complex data set that you were managing and playing with. Tell us a little bit about what you found.
So, some of the things that we wanted to compare were how testosterone related to antler size and body size, since these two traits are two of the most important things that contribute to reproductive success for deer. We found that for the most part, testosterone was positively associated with antler size and body size. But when we broke it down by age categories, this was only true up to the age of 5.5. Once we got to the 5.5-year-old deer, this trend actually reversed and we saw a negative association. So the deer with larger bodies tended to have lower testosterone, and the deer with larger antlers tended to have lower testosterone as well. So when we ultimately compared how testosterone might relate to reproductive success when we account for antler and body size and age, we found that antler and body size alone were the top factors that were associated with greater reproductive success. Um, so it might be that testosterone is indirectly affecting reproductive success through these two avenues. Again, when we account for age, we found that testosterone doesn't have the same impacts across all of our age class deer. So those
Sure.
deer that are up to 4.5 years of age, we found that positive association between testosterone, antler and body size, and reproductive success. But again, once we got to the older age class deer, it was a negative association, which was a little surprising to us since we know that testosterone is associated with those dominance behaviors that are really important for a sexually selected species like a deer.
Yeah.
Um, Everyone's really familiar with how they fight with their antlers. They really wear themselves out during the breeding season. So you would think that having that hormonal kind of drive to be more aggressive and have more energy and exert more energy would play a positive role regardless of what age the deer is. Um, and that kind of led us to conclude that as deer age, there might be different strategies that work to obtain reproductive success for them.
Oh, yeah. Interesting. Yeah, that's really wonderful. And all of those factors that you were able to put together to really make a more complete story is really, really compelling. So as you think back about this study, setting it up or anything throughout the process, What are three key takeaways that you kind of gleaned from your journey along this path?
I think one of the biggest takeaways that I've had from working on this project is just the importance of long-term exploratory research and long-term data collection. I would not have been able to study the topics that I did and the depth that I studied if it weren't for 10 years of graduate students running this
Mhm.
project.
Yeah,
And I've been very grateful to work on that project for both my master's and my PhD and kind of continue with that data collection. But it's really incredible the kind of insights you can get from a project that really commits to that long-term data collection. So that definitely was the first biggest takeaway that I would say from this
yeah,
project.
absolutely.
Um, a takeaway with um, I would say, like, my lab work was
Yeah.
that it would take me a lot longer to complete all of these samples in the lab setting. There was a little bit of trial and error, but ultimately, I think that, it's really important that whether you're a field scientist or a lab scientist, that we really merge those worlds together
Mhm.
because ecology doesn't happen in a controlled setting, and at the
Sure.
same time, ecology doesn't happen without the fine scale mechanisms of all of these other processes that are going on, like endocrinology.
Yeah, absolutely.
So the merging of those two worlds would also be very important. And then thirdly, um, I think it's really interesting that even in species that we do know quite a bit about, white-tailed deer are one of the most studied game species. We still have a lot to learn when it comes to their entire life history. We only get to study them a lot of times with just a snapshot of their life. And when we can have the data that shows us individuals on a fine scale level, we can really learn quite a lot from analyzing them at different points in their life and breaking down the differences between each individual.
Yeah, there's something really beautiful about knowing how much we know and how much we still have left to learn for both
Yeah.
individuals as well as on a whole population level.
Mhm.
Awesome. Well, thank you so much for sharing all of this wonderful research that you've done with us today, Monet. And thank you, everyone, for tuning into this episode of Research Recap. We hope you enjoyed exploring the exciting research that was done by Monet and her colleagues. If you have any questions for Monet, please feel free to contact her at the information shown here on the screen. If you or someone in your lab has published work using our kits and would like to be featured in a future episode, please be sure to email us at marketing@arborassays.com. Until next time, have a great day, and we'll see you in the next Research Recap.